So f of x, if you factor the numerator, you can pull out what first? Oh, thank you. You can pull out what first?
4.
Girls, please sit. We're working on this together now. 4x squared plus what? 7x plus 12 over. What do you have to use to factor this? Grouping. Use grouping. So what can you factor out of the first two terms? X squared is going to be x plus 2. And what do you factor out of the second? Negative 9. So you factor out that out because you want to get the same thing in both places. That's the whole point of grouping. What does the numerator factor into? You notice how I'm skipping lines. There's space between it. It doesn't just look like one nasty thing over a thing over a thing over a thing over a thing. Space your work out with lines and equal signs and equations. What can you factor the numerator into? X plus, anybody? 3 and x plus 4. And then the bottom, it's x squared minus 9, x plus 2. Are you done factoring? Nope. Which thing can you still factor? Yeah, the x squared minus 9. Exactly, Chris. So it's f of x equals 4 times x plus 3, x plus 4 over x plus 3, x minus 3, x plus what? 4. What do you do now before you do anything else? State the domain. Literally write the word domain. Yes. Oh, thank you. That would have been catastrophic. Yes. So what's the domain? Can someone tell me what the domain is? X such that what?
X such that x
can't be?
minus 2, -3, 3.
Yep, good. Now what do you do? Now you cancel. One thing does cancel, and what cancels? That becomes a what?
Whole.
So that becomes a whole. And what's the x value of the whole going to be? Negative 3. Keep in mind, all of this is going live into your notebook, everybody. All of this is going live into your notebook, just so you remember that. Negative 3. How do you find the y-coordinate of the whole? How do you find the y-coordinate of the whole? Yeah, so you go back to your canceled form. You write the simplified form here. Please write this in over x minus 3, x plus 2. What do you plug into this? We want to plug in our negative 3 into here. So if we plug in our negative 3 into there, so not g, what is it? We're calling this function f. F of negative 3 is equal to 4 times negative 3 plus 4 over what? Negative 3 minus 3, negative 3 plus 2. What do you get? 4 times 1 over what? Negative 6 times negative 1 is 4 over 6, which is 2/3. Is that correct? What do we think? Is it supposed to be 2/3? I think so. So we have our whole. After you do the whole, you can do things in different orders now. What should we do next? What should we find next, Vic? Which one? Be specific.
Let's do asymptote.
Which one?
Oh, x. Or vertical asymptote.
Vertical asymptote, right? So the vertical asymptote, you look at the simplified form, which is right here, and you look at what can't we plug into the denominator? Well, what's one number we can't plug into the denominator? 3. And what's the other one? Negative 2. And for the horizontal asymptote, you look at just the leading term. Look at the original. What are the leading terms here? There's 4x squared and x cubed. What's the power in the denominator? 3. What's the power in the numerator? What's greater? If the power is greater in the denominator, the horizontal asymptote is always going to be what? Y equals 0. You can use the end behavior to determine what side it's approaching from. We have a ton of information right here. What I've seen a lot of is that people are getting hung up on the next thing, which is figuring out the end behavior. That's fine, but if your goal is to make a graph, take all this and use it to help you find the end behavior. Take all this and put it on the graph and see what it looks like. Many of you are getting to here, crushing through it, and then spinning your wheels for a while because you're not looking at the whole picture. If you filled in this much of the picture, it's really easy to figure out the rest, or I think easier. So let's plug in some things here. What do we have here? We have oh, we haven't done the intercepts. Thank you. Yeah. The x-intercepts are when what? Y equals 0. So that's when 0 equals 4 times x plus 4 over x minus 3 times x plus 2. What's the only way to make a fraction equal 0?
0.
0 over something, right? Not 0. So 0 in the numerator. So you're solving what here? What do you solve? 0 equals what?
0 equals 4 parentheses x.
Yes. So what does x have to be? Negative what? Negative what? Yeah, negative 4. Sorry, the jet was drowning everybody else. So negative 4. So we have an x-intercept at negative 4 right there. Do you agree with that? We good? Does it match? How am I doing? Am I doing okay? Okay, what about the y-intercept? How do we find that? That's when what is 0? X is 0. So that's when we have 4 times 0 plus 4 over 0 minus 3 times what? 0 plus 2? Is that correct?
Yeah.
So what do we end up with? 16 over what? So that's 8 over what? 3. So the y-intercept is, so negative 4 is 0, and this one is 0, 8 thirds. That's like 2 and 2 thirds? Thank you. Negative. Very good. If you make that mistake, it can mess up everything, right? If it's the wrong point. So that's like negative 2 and 2 thirds. Yeah. So I'm going to label it right here. Where was our hole? Negative 3 and 2 thirds, right? So it's like right here. You see that I just put in there? Where are vertical asymptotes? We have a vertical asymptote where x equals 3. So we have a vertical asymptote right here. At what? X equals 3. And where's the other one? Negative 2. So we do this, right? And where's our horizontal asymptote? What's that? It's right here. Okay. At this point, let's look at what we know. We know a ton. It doesn't look like we know too much, but we know a ton. How many x-intercepts does it have, Vic?
1.
Does it have any others? Can this graph cross anywhere else on the x-axis?
No.
So what does that tell you about what the shape has to be down here? Can it go up from that point?
No.
It has to go what?
Down.
So you know it has to go down here, and it has to go down there, because it can't go up. Good so far? Look at this right here. What's the degree right here? What's the degree? 1. What's the degree here? So this vertical asymptote that comes out of that is 3, and this one is x equals what? Negative 2? Since the degree is 1, 1 is odd or even? So if it's odd, Chris, what does that tell you about the direction the arrows have to go in? Same or different? Switch, just be different, right? So if we know it has to go down here, what does it have to do on the other side? It has to go up. And does that kind of match these points right here? If this goes down, what does the other one have to do? What? Up. So it has to look like this. What's the one piece of this graph I haven't drawn yet? This thing, right? And what's weird about that? What's bothering you right now about the negative 4? Can you cross, careful, can you cross a horizontal asymptote?
Oh, yeah.
You can, right? But here's the thing. It goes to 0 again, right? So what does this graph actually do? It crosses, but then what does it do? It crosses, but then what does it do? It goes back up. This graph crosses it because it has to touch, but then what does it do? It goes back up and approaches from the other side.
So is it a parabola then?
The exact curvature is not a parabola, and it's something we don't have the tools yet to analyze. But we know it goes back to 0, right?
Yeah.
But it has to cross. There's one point on here that we don't have that would be really good to have. I know I'm over a little bit here. What would be a really great point to know that we don't have the tools yet to find out? What? Well, there are no other x-intercepts. We know that for a fact. There's one piece of this that we don't have yet. What is it? We don't know the location of something here. The bottom point. It'd be really helpful to know what that is, right? Because it might go down and then back up, or it might go down a little bit and go back up. We need more calculus, and we will soon find out how to find that. Soon. Not yet, but soon. Get out of here, everybody. Thank you for your time.